Hello, and welcome back to this YouTube channel, Math and Science Problems. Today, we will be going over the golden ratio. Before we start, please take some time to like, share, subscribe, and comment any questions that you may have after watching the video. With all of that being said, let's begin. So, one may ask, what is the golden ratio? Well, the golden ratio is 1.618. Now, from last video, we talked about the Fibonacci sequence, and the golden ratio is a heavy factor when it comes to the Fibonacci sequence because the golden ratio was kind of used as a balance. So, as stated here, the golden ratio is 1.618. Now, this number was used to show that something was perfect or, in a sense, a great measurement when creating walls or pillars or anything under the sun when it comes to architecture. Now, to get 1.618, which is the number that they usually wanted, putting the golden in the name, this is the formula that they would use. So, A plus B, when A and B are any integer, divided by A is equal to A divided by B, which is equal to a number, let's say X. Now, this equation right here is saying that the ratio of A plus B divided by A is equivalent to the ratio of A divided by B, which gives you a number which is most likely going to be the golden ratio. Now, this formula right here does not work for all numbers. For example, if I were to say A is 3 and B is 2, 3 plus 2 is 5 divided by 3, and then 3 divided by 2. 5 divided by 3 and 3 divided by 2 is not the same answer. 1.67 and 1.5. This goes to show why the golden ratio was known, because finding these specific measurements and being able to calculate based upon the result was heavily infatuated by the people building and using math when it came to these objects in different shapes. So, the golden ratio only works for certain integers, and we will be able to explore these integers. So, let's practice. So say I have A right here is equal to 1.618, which is the golden ratio. And say I want to make a really cool rectangular rooftop for a house. So A is equal to 1.618, and let's say B is equal to 1. So say we're an architect and we're designing a house and we're looking at this on a 2D or a two-dimensional spectrum. So my length would be, or my width would be, whichever one you want. My A would be 1.618 and my B would be 1. And so because there's a difference, it would be a rectangle. So if we take these two numbers and we add them, we would get 2.618. Now, this is this part. We just completed this part. Now, if we take A plus B, which is 2.618, and we divide that by 1.618, This is equal roughly 1.618, which is this. Now, if we take A and we divide this by B right here, anything divided by 1 is simply 1.618. Now, understanding this from the Gordon ratio perspective, we were able to take the addition, A plus B, and we got 1.618 plus 1, and we got 2.618. And once we divided that by A right here, which is 1.618, we got 1.618. Now, we stated that from the Gordon ratio, A divided by B should be equivalent to the ratio of A plus B divided by A. So, we took 1.618 and we divided that by B, which is 1, and we received 1.618. So this was a concrete example on how the Gordon ratio can be used and applied to certain numbers. Now, through multiplication theory, if we took an approximate number, because the Gordon ratio can be roughly rounded to 1.6, and we're still going to use 1, so approximately or actually 1, we could multiply both numbers by the same unit or number, and the Gordon ratio would still apply. So say I took 1.6 and I multiplied that by 7. We would get 11.2. And since I multiplied 11.6 by 7, we have to multiply 1 by 7. And 1 times 7 is 7. So after doing this, we could apply the Gordon ratio again, still obtaining the same results. So if I were to just repeat the sequence again, I would still come up to the same answer because I multiplied both units by the same number. And also, just to ensure this, if I were to be given 11.2 and divide that by 7, I would approximately get 1.6, which is going back to the clarification of the rounding of 1.6 over here. So from this, we can see that through 1.618 or 1.6 and 1, if we multiply any number by that, whether that's a rational or irrational number, the Gordon ratio can be applied. So I like to give this and spread this knowledge to you because you'll be able to understand and see the different units that can be used when it comes to the Gordon ratio, and in terms of architecture and design and seeing different buildings, these given measurements can be understood through the Gordon ratio through this formula. So through all of this, we were able to understand the Gordon ratio and how that can be applied to two-dimensional objects when giving certain measurements, and how to find those measurements through A plus B divided by A, which should be the equivalent ratio to A divided by B, which gives you a number X, which that number X is the rate or the approximate number that they are equal by. Thank you so much for watching this video. If you have any questions or comments or concerns, please comment them down below. Please remember to like, share, and subscribe. And I hope you enjoyed this video on the Gordon ratio.